All right, so I'm back here today doing a amplifier update. From this point, it has been about 3 months since I first started the project. That was coming from the inception of laying it out, all the way to now, where I have the enclosure built and some of the electronics already in place. So I just wanted to do a quick overview. A couple weeks ago, I did a layout video concerning how I would lay out like the transformers on the other side and all that. But since I'm at this point, and I reached a stopping point earlier, I figured it'd be a good time to do a little layout review of how I have things laid out inside the amplifier. So, well, first things first, a couple weeks ago, I decided that I would get a PCB board made for the 6-volt DC and standby switch. So that's what this is here. This is the B plus power supply. This is the 6-volt DC for the 6SN7 and the standby switch circuitry. And this is your signal path here. So why did I go with a standby circuitry? That might sound unusual for anybody that's familiar with amplifiers. Typically, a standby switch is nothing but a switch to ground at the center tap of your power transformer. Though, I'm not using the center tap here. Why am I not using the center tap? Well, because I'm using a bridge rectifier. So typically vacuum tube amps will be constructed with a full wave rectifier, and that enables them to be able to use the center tap. This is a little bit different. When you use a bridge rectifier, you can't use the center tap as your ground for a standby switch. So I had to construct something else. So what I did, and I'll put a image up of the circuit. I have another video explaining the circuit, but I'll briefly discuss it here. All the circuit is it's the switching transistor that operates this relay, and this relay, the switch to this relay is tied to one leg of the AC voltage secondary that comes out of the transformer, which is about 180 volts. So when I hit the standby switch, which is going to be this switch here, when I hit the standby switch, it'll take about 1 second to trip this relay, and that relay will close, and then that leg of the primary, that one leg of the primary, will complete the circuit going into the full bridge rectifier. And that's how my standby is going to be done. Now I actually have to make a modification here on the underside of this, is that it's this 470 microfarad capacitor that charges this resistor to turn this relay on. Though a 470 microfarad cap is quite large when you have to turn this off and wait for the discharge. So I need to put a discharge resistor on this capacitor so that it doesn't, and right now it'll take about 10 seconds. So it works, it'll take about 1 second to turn on and flip, which is great, but it'll take actually about 10 seconds for it to turn back off because this capacitor has to discharge. So I'm going to put a discharge capacitor. I could make another video about that, but it's pretty basic. So all you're going to do is put a high resistance resistor paralleled with the capacitor, and that'll discharge it when it turns off. So so that you don't have any voltage waiting in it. And a lot of times you actually do that in even B-plus circuitry, just so there's not the amplifier doesn't retain high amounts of voltage all the time, because large capacitors can contain voltage, can retain the voltage for a number of days, even if it's not turned on. So that's what this is. So aside from that, things are coming together pretty good. All I want to do is kind of point out, what tend to be, quote unquote, I guess the problem areas, you could say, are things to watch out for when you're constructing an amplifier. As I talked about before about the transformer placement, when you're laying out the amplifier, you're wanting to orient your transformers in a certain way to evade any kind of EMI, some radio interference, or some electromagnetic interference, right? So most of your efforts in constructing your amplifier, aside from the circuitry, is going to be put into noise reduction, right? To how to manage noise, right? There's certain things that are going to cause noise. Power transformers are going to cause a lot of noise, and the power coming out of those transformers is going to cause a lot of noise. So mostly what we're doing here, when you're constructing an amplifier, what you want to pay close attention to is your AC lines, right? So thankfully in this amplifier, it's pretty simple, and I designed it to where the only actual AC line that's going to go near the signal path is this 6-volt winding for the KT66 for the output tube. Other than that, I did a DC voltage. I did a DC winding for the 6SN7, which would be considered the preamp tube or the gain tube. Now I did that to reduce noise, or reduce the possibility of noise, because it's much more plausible that I'll receive noise from the preamp tube than from the output tube. So to cancel out the occasion in which the preamp tube would make any noise, I just did a DC winding on it with some high filtration there, and that should take care of it with no issues. As you can see, this 6-volt winding is really close to the chassis, right? So you want to keep this away from any signal. This is also a DC winding, though it's just for the LED. That's just for the on LED. But even in the situation of an on LED, right? LED, like that's just your, on indication LED, but it's carrying, that's 120 volts AC in there. So I just don't want that to be strung across the amplifier going this way, or strung across here, even though there would be no reason for it to come anywhere near here. It's just something to point out, right? So this is even going to lay right against the chassis, going into the switch and the connector. So those are the two main areas. This particularly, this filament winding. Your filament winding in a tube amp is usually where you pay the closest attention to as far as avoiding hum. Now, another important thing to mention for those that might not be familiar is that these wires are twisted up for a purpose, and that's to cancel the hum. So if you twist the wires of an AC signal, that will help reduce the hum, cancel the hum. It's the same kind of idea that you see in guitar pickups with a single coil as opposed to a humbucker. You have those two coils next to each other. That's an AC signal. What you're playing into your guitar is an AC signal. And that AC signal, some of that noise will cancel out when you put them next to each other in the case of the humbucker. In this case, in AC wiring, if you twist them together, that'll cancel the hum. So you want some really tight windings here. As you can see, this is the 6-volt winding coming out of the transformer, real tight, going in to the board, really tight, and most importantly, coming from this post to the KT66 coming here real tight and being placed against the chassis. So all I have left out here, this is coming together. I've done this wiring. See, like I said, it's been 3 months since I thought of doing this. Came out with the parameters, developed the schematic, ordered the parts. I built the chassis, which is something that you don't have to do. If this is something that you're thinking about doing yourself, I'm actually going to make this schematic open source in the end. So that's something I'll talk about later as well. But I'm going to make this available for anybody that wants to build one. So aside from that, you don't have to build the chassis. That's one of the things that took me the most time, is to make this chassis, because I built this from scratch. But you don't have to do that. You can get enclosures from Hammond. You can get enclosures from Tube Depot. You can get enclosures online. I mean, you could really even recycle an old piece of gear and use that as an enclosure for the amplifier if you'd like. You don't have to, and you don't have to build it from scratch, and that's going to save you a lot of time. So that's what took me the most time, is to build this enclosure. Now, the circuitry that you're seeing, all this wiring and layout and placing the components, I've done in the last 3 days. So this is not actually that intensive when it comes down to just soldering the parts. It's pretty simple. So the only thing left I have to do is wire the tone controls and develop a grounding path. That's going to be another thing that's going to be really important, and I'll probably share that in another video when it's done. But this is why I've come to a stopping point, because I'm thinking about how I want to ground this thing and where I want to put the components for the tone controls. So all in all, this layout has been really good, and I like the design of it. But this is part of why I wanted to do this video, is to share some design flaws that were inbuilt in this thing. So one of the design flaws that I've come across is that having the tubes in line with each other like this causes there to be quite a distance between the tone controls and where it meets the preamp out. Right, so if I just grab a tape measure real quick, I'll show you the distance between here. Because this is the only thing that's really become kind of problematic. It's not the end of the world, but again, when we're talking about constructing an amplifier, we're talking about trying to keep your distance between parts very minimal, and your distance in crossing power very minimal. So you don't want your signal lines to cross over your power lines, especially your AC power lines, which this won't in this case, but it's still quite a distance. So the longer your signal lines are, you're basically making them into an antenna, essentially, is how you look at it. So the longer your signal line is, the more propensity it has to be able to pick up unwanted noise, right? So if we go here, see, it's about 6 inches. See, so that's the only trouble I'm having, is from where the tone control is to where I have to tap it out of this capacitor is about, well, it's actually about 5.5 inches there. Which, if this tube was up here, if I did it like this, if you look at this in a vertical way, if I did this horizontal and move this tube up here, then it would be like 2 or 3 inches. So that would have been better. It wouldn't have the same look. I did that mostly for cosmetic reasons, is why I have it in tandem like that. Again, it's not the end of the world. I don't think it's going to make the difference between this thing being a noise factory or it being quiet. It really has to do with a lot of the things I mentioned earlier about how I'm running my lines and some of the design's characteristics and choosing the components. But one thing that I'm going to do to evade having any kind of issues with noise given this distance is I'm going to use some microphone cable, or you can use some just RCA cable, some high quality RCA cable, instead of doing something like this. Now, this is what I'm not going to do, okay? This would be one of the worst things you could ever do, especially if you're in this kind of situation. Now, I wouldn't recommend doing this even if in a situation where I only had 2 or 3 inches. I would still probably use some signal cable. But this would be the worst thing to do, is just to use some hookup wire. Now, this stuff is great for your power lines. It's great for your AC. It's great for your DC. It can be used for parts. If I had to, string a component along in a further distance, I could use that there. But there's critical areas where you don't want to do something like that. To just use hookup wire. You want to use something more substantial. You want to use some signal wire. And most of the reason for that is that this is shielded and it has grounds, right? So what I'm going to do is use this to get to my tone control. And this is also going to be, in the end, you'll see 2 strands of this. There's going to be one strand here for my tone control. There's also going to be another strand about here for the input jack going in to the input resistor that goes into the grid of the first tube. And that's how I'm going to solve my problem of there being this extraordinary amount of length between my tone control and the hookup. So yeah, that's really it. That's been the most troublesome encounter I've had in the construction of this amplifier. Though, like I said, it's an easy solution. If you just use some high grade signal wire, then you're good to go. So I'll probably have this done in the next coming days. Again, the next thing would be not only to hook up that signal cable for the tone control and the input, but also I have to figure out a ground path. I don't know if you can see this, but if you look real closely, like this resistor here, it's just hanging in the wind, right? And this one is too, and this one is too, and this one is too. So I haven't had the ground path. Like, this is not an amplifier I'd want to turn on right now, even though all the things are, all the components are hooked up. I would get some power running. I could measure some voltages here and things like that. But this thing is it's still floating, right? There is no ground path because I haven't laid it out yet. So this is the last 2 things I need to do is hook up this signal cable and construct the ground path. And now I'm going to I'll talk about that a little bit, but I'll probably make another video about that when I get around to doing it. So what I'm going to have here, just to talk a little bit about it, what I'm going to have is a thick copper wire coming mounted to the chassis, and it's going to be snaked along where I have these grounds sticking up, and the grounds are going to hover on top. And then I'm going to have another one for my power side, which is going to be minimal. I think I only have a ground point here, from here to here, and then at this capacitor here. So there's only 3 ground points on the power side, and there's about 4 ground points on the signal side. And there'll be 1 lead coming from this end, from the signal side, and 1 lead coming from the power side. And then I'll tie them to a star ground at the bottom, at the plate, or what's going to be the bottom of this amplifier. And that's how I do my grounding. Again, I'll make a follow-up video about that because that's really important. One of the things I just mentioned that's really important about that is having the ground and your signal separated. So the ground, the signal ground is going to be on a separate bus, and the power ground is going to have its own bus. It's really important to do that, to have a separate bus for your signal and a separate bus for your power. And I'll show you more and talk about that more as I get around to doing that. But 3 months out, here's the development of the amplifier. I'll also maybe post some pictures of the outside and how the exterior of it looks. You can get an idea of it there. So yeah, I appreciate you watching. Thank you.